This video demonstrates the process of generating a rotating magnetic field in an induction motor. Consider a coil with N turns and apply an alternating sinusoidal voltage to it. The current passing through this coil will also be sinusoidal, but it will lag the voltage by 90 degrees. For actual inductors, because of their internal resistance, the phase angle is not precisely 90 degrees. Here, for simplicity, we assume that the resistance of the windings is negligible, and this assumption does not affect the essence of the matter. According to the right-hand rule, the current generates a magnetic flux in the direction you are observing. Now, when three coils are subjected to three-phase voltage, the outcome will be as observed. If three similar coils are present and three-phase voltage is applied to them, the resulting outcome will be as observed. The phase difference of the voltages is 120 degrees. As you can see, due to the phase difference of the voltages, the fluxes also exhibit the same phase difference. In other words, the fluxes have a phase difference of 120 degrees in terms of time. If these coils are placed 120 degrees apart from each other, the resulting configuration will look like this. Now imagine the coils are arranged in a circular manner with the same phase difference. Then the flux vectors for each winding are plotted and centered. These vectors are then summed together. The result is a flux that rotates with constant amplitude. This vector represents the combined flux of the three coils, depicted in yellow. The amplitude of this vector is 1.5 times the flux amplitude of each coil. The rotational frequency of this flux vector is directly proportional to the frequency of the voltage applied to the coils. As the frequency increases, the flux rotation speeds up, and vice versa. In subsequent videos, we will explore the factors influencing the speed of this rotating field. Consider an induction motor stator with only 6 slots and 3 coils. While real stators typically have more slots and coils, we've chosen 6 slots and 3 coils to avoid complexity. When three-phase voltage is connected to the stator, a rotating magnetic field with constant amplitude is generated inside the motor. Additionally, the magnetic flux lines for a bipolar motor follow a similar pattern. However, it's important to note that in reality, due to the non-uniform distribution of flux on the coil's surfaces, the amplitude of the rotating field varies throughout the stator, leading to potential issues. To address this problem, distributed winding techniques are employed. In upcoming videos, we'll explore how windings are distributed within the stator. Please subscribe to our channel, ring the bell for notifications, and share our content with your friends. Leave us a comment if you have any questions or suggestions.